Okay, so now we are, sorry about that. Okay, now we're going into domains of functions and like trying to find and graph and analyze these functions. Okay, so a square root function. Basically, we can also go into the y equals on the calculator and just let's see how it works, how well it works. X, great. Now we'll press graph. See, there you go. We have something like that. Awesome. So we'll always start at, it will start at 0. We'll start at 0 and 0 because 0 at, because look, if square root of 0, 0, so 0 and 0, and then 1 and 1, since square root of 1 is 1, and then 2 and 4 because square root of 4 is 2. And another thing is, look, we can also go into here, second table, and then look, 0, 1 is 1, 4 is 2 because we want a real number, like a good number. And the next thing we see is 9 and 3. So now we can graph this over here as well. Yeah, and okay, let's see. I think I want this turned up just a little bit. Okay. 0, 0, 1, 1, 4 and 2, and 9. Okay, I'm just gonna pretend that this line is 9 and 3. I don't think it really matters until test day. You just have to know to look for 9 and 3. Okay, so now I didn't really go deep into how to find domains and ranges and stuff like that. So here, basically, domains asking what x values are allowed. So what you should think of when you're trying to find the domain is what would make the function impossible. So let's say, so a denominator of 0 is not allowed. An even root of a negative number is not allowed, and a logarithm of 0 or negative is not allowed. So let's see. What would the domain and range, be for, we're trying to ask, what would the domain and range be for square root of x? Wait, has it not been typed? Oh, that's so annoying. So what would a square root be? What would okay, whatever, you get the point, you can listen. So now we're trying to find what the domain and range be for square root of x. So the domain, the expression inside the square root must be greater than or equal to 0. It must be x is greater than or equal to 0. So the domain is this. So it basically is that. Okay. And then the range, square root can never give a negative answer. So the smallest output has to be 0. So the range would be y is greater than or equal to 0. That's just what it has to be. And now the minimum value and the minimum value, in order to find that, you can go into here, second calc, minimum, left bound, so I don't think there can be a minimum number. Okay, so the smallest value, because it's 0. By the way, I should not have put that line all the way down there, because it starts at the 0. It can't go beforehand. So the minimum is 0, but there is no maximum. It just keeps going up. Like, you just have to know that if it's not like a thing that curves down, it's just going to always go up. Okay, are there vertical asymptotes? There are none because the graph starts at 0, 0 and doesn't shoot up towards like the infinity near any x value. So there's gonna be no, so it wouldn't like stop at like a certain point or whatever. But horizontal asymptotes, there's also none, since x will go to infinity. It'll keep on going. Okay. So now we can do we'll do cube root, and then we'll do the square function, and then linear function and cube function. Okay, so cube root. Great. So let's start off here, because it's -8 and -2, because cube root of -8 is -2. -1 and -1. Because we want to keep going down like this over here. So 0 would be 0, 1 if it's calculated 1, 2 calculated 8. So 2 cubed is 8. Okay, because you always want the y to be a big number, and that's just how you're supposed to set it up when it's a root function. When it's a root function, you always have to do, you don't have to, but you should, in order to make it a lot less confusing, always start with the y. Start by -2, -1, 0, 1, 2, so on and so forth. Because if you don't, then you might end up with some weird numbers. But it's vice versa for any other type of function. So now we can graph it. -8 and -2. Again, I'm just going to make believe that this is 8, but be sure that on the test to actually try to make sure. -1 and 1, 0 and 0, good, 1 and 1, 8 and 2. So now I have this. Okay, so now let's try to find the domain and range and all that stuff for cube root of x. Sorry, someone just texted me. Alright. Okay, awesome. So now I'm trying to find the cube root of x. Okay, so now the domain and sorry, whatever. Okay, so the domain is all real numbers, because any number can go in the cube root, because it can be negative numbers, it could be 0, it could be whatever. And the range is also any real number. This is the symbol, by the way, for real numbers, because the range can be from negative to positive and whatever. Now there is no minimum value or maximum value, since it's not really curving downwards. Minimum maximum would be found something like this. But here there's no minimum, no maximum. Now vertical asymptotes and horizontal asymptotes, there is none. And yeah. All right. And again, I'm not sure if I explained this before, but vertical and horizontal asymptotes. Vertical is when it just is about to reach the y value, like just about to, but it never will touch. And then horizontal is vice versa. About to, never will touch though. It'll always keep coming closer, but never fully touch. Okay. And, wow. That is a lot of storage. Why is it so much? Okay, I should get going. Okay. Absolute value function. Let's just skip that. That's simpler. Okay, so now remember, since it's not square root, we're gonna start by doing on the x side. 0, 1, 2, 3, And then if you put it all into square, so you get 9, 4, 1, 0, 1, 4, 9. And then you can graph it here, -3 and 9, -2 and 4, -1, 1, 0, and then just the opposite side. You can eyeball, it's easier for me to eyeball this, whatever. Okay, the domain is all real numbers. Range is y is greater than or equal to 0 because it doesn't go below that. But the domain, because the x values will go left and right. Minimum is 0, 0, and there is no maximum. The x and the y intercepts are 0, 0 because that's where they both meet. And there is no asymptotes. Okay, let's graph. Let's get the linear function. That also is just diagonal line. Yeah. Domain and the range is all real numbers. X and y intercept are 0, 0, and there are no asymptotes. Okay, now cube function. Let's do that again because it's not square root. We're going to be starting on the normal side, on the x side. And then if we put it in, again, I'm just looking at the answer sheet just to speed up the process because this video is already taking up a gigabyte. Domain is all real numbers. Range is all real numbers. Here I can graph it if you like. -2, -2, wait, 1, 2, and 8, 1 and 1, 0, 0, 1 and 1, 8. Hey, and basically the minimum will be 0, 0. No. Oh, I'm a little stupid. It will be going like this: -2 and -8, -1, -1, right? And then so it'd be going like this. So there is no minimum, no maximum either, no asymptotes also because it's not gonna, because it's already gone past the thing. It's not gonna come any closer to a y or an x thing. Okay. Now explain how the following graphs would be changed from the regular y equals x. Okay, so always remember that -2, minus is down, plus is up. Okay, so minus, you're subtracting, you're going down in level, you're adding, you're going up in level. That's like something to do it, I guess. When it's in parentheses, x plus 2, I guess, whatever, to the power of 2. When it's in parentheses, plus means left, and minus is right. And yeah, when it's negative, it means reflect on the, so negative equals reflect on the x-axis, and negative in parentheses with the square out of it, it means reflect on the y-axis. Negative parentheses, so this is just a combination of a bunch of things. So you reflect in the x-axis, you go up 1 because of here, you reflect because of here, and you go to the right 2 because of here, the negative in the thing. Okay, now 2x there. So now when there's a coefficient, it means that you're stretching. So you're stretching by a factor of 2. And over here, and it's a vertical stretch. Over here, it's a vertical stretch by a factor of half. Okay, and then this video now.